So next, at 12:35, just pretend this is 12:35. Modern data platforms secure access to trustworthy data as and when needed, enabling the data experience. So we have Nitin and Ajay. So Nitin is the chief technology strategist for Oracle Government and Education, and pretty much he writes books, he presents. There's not much he doesn't know about anything to do with databases, high availability. He's written books as well, and yet he spends serious time on the golf course. He says that it's all actually specifically so that he can analyze it with the Oracle data analytics. But so that's Nitin. Yeah, I'm not sure where he finds time to do all the things that he does. I've got like a whole page here. I'm just summarizing some very high level. So, and Ajay is also very experienced. Ajay, I see we've still got your name incorrectly spelt on this. It's meant to have an E on the end of it. So Ajay Padhye. He's got over 20 years of experience working with Oracle technologies, healthcare, manufacturing, government, and education. He began as a PeopleSoft developer. I know a lot of people who started that route. Um, and But he's specifically very experienced with everything to do with this platform, even the OCI aspects of it. And which he does for fun, which for me would be punishment. He's done 100 miles bike ride, which he achieved just before COVID kicked in. So with that introduction, Nitin and Ajay, let me hand over to you if you want to take the screen from me. We look forward to hearing your presentation.
Thanks, Roger. Thanks, Adel. Thanks for everybody else for inviting us. Let's see. There's always some kind of weirdness that happens. Can you guys see the screen? Can you guys see the?
Yep, perfect. Thank you.
Excellent, excellent. Okay. All right. So I'm not going to go introduce myself since Roger did an excellent job introducing me and Ajay. Ajay, unless you want to add anything.
Nope, I'm good. We can get into the content.
Yeah. All right. So great. Thanks for having me, guys. As Roger mentioned, I'm an avid a player in the data space. And what I'm going to do is interesting because I listened to Mike's presentation, listened to Holger's presentation. It was great. So we're going to actually draw on some of those things. Unbeknownst to us, we didn't know what they're going to present, but it's great. It's a nice little dovetail into our presentation. So my name is Nitin Vengurlekar. I am the Chief Technology Strategist in Oracle Government and Education. And as part of my role, as my title says, I help define strategy inbound, as well as working with customers in their monetization effort, a lot of their data management efforts. So I get a chance to really work with some really big data platforms, working with US Treasury on their fraud detection, state and local agencies on some statewide initiatives such as criminology, or Medicare and Medicaid, which is one of the data sets we're actually going to touch on today. And as well as working with some really big, large universities, as well as some school districts on, ransomware and data protection. So I get a chance to see all kinds of things, right? So this is going to be great to talk about some of the data management stuff. And our presentations are going to be partly philosophy. What are the things that we do when we talk to and start working with these big customers with their really large data sets, right? So these data sets we're talking about are multiple petabytes of data sets, especially when it comes to really secure data, such as the PII, PHI data. It's in human health services like Medicare and Medicaid. So let me kick this off. One of the things we're going to cover today is a modern data platform, like as the title says, and as it deals with data strategy for the digital transformation era. So we're going to talk about what are the considerations for a modern data platform, right? So what are the key components in the modern data platform? And at what point should organizations start to think about transitioning to what their current environment is, if they're currently running BI analytics or whatever it is, to a modern data platform, right? But also want to talk about some of the automation that's key, right? So you're going to hear me say this a lot, is that we don't want you to just modernize and just upgrade things, right? There's a lot of automation that could be built into this. So there's a lot of advancement that could be done. So we want you to modernize with the purpose and build in automation, use low-code, no-code approaches, use machine learning where it makes sense, right? And also talk about how a converged database or a unified data tiers, which supports multi-model, multi-data type support, plays a part in this. So, all right, off to our journey. So digital transformation, this slide makes a lot more sense when you're in person walking around and polling people, but here it is. If you ask 10 people what digital transformation is, you're going to get 13 answers, right? And that's not to say it's because digital transformation is nebulous or ambiguous and it's, you can't really put your arms around it. It's because it means different things to different people based on where they're coming from. So for example, here's 3 examples of, for Gartner, CIO, and Accenture have their definitions, right? So each organization focuses on digital transformation based on a specific area. It could be people, organization, processes, or technology. It's really all about digital transformation, fundamentally how it reimagines businesses and agencies and how they operate. That's kind of the way I look at it. So I'm going to throw my definition to the hat as well, too. I'm honestly just like Accenture, right? So to me, digital transformation is all about becoming a digital enterprise and using data. That's the key. I should put it in bold as the catalyst for that journey, right? So it's not just about using digital technology in a specific business case, but rather embedding key digital capabilities across the organization and really applying business outcomes. At the end of the day, you have to achieve business outcomes, or you're just doing, upgrading your stack, right? So when we talk about business outcomes, it could be something like empowering business users with immediate secure access to data, or improving operational efficiencies, or providing streamlined services to customers. In our case with government and education, it could be patient 360 or citizen 360 approaches, right? So everybody has different definitions. So now that we kind of established what digital transformation is, let's talk about how data, as I mentioned, that should have been in bold, how data influences this part and where data plays a part and where data matters. Right. So if you look at this on this left-hand side here, you have this slide where you have the purple side, which is the historical part, right? And that's business intelligence, or BI. So as you guys know, business intelligence deals with what happened in the past, how it happened leading up to the present moment, and identify some big trends and patterns without digging too much into the prediction of the future, right? And that's how BI is and how it's always will be. And again, BI is not going away anytime soon. We're always going to need it, especially for commercial companies that have to do some level of reporting to stock markets or their stockholders, right? So we're always going to have a BI always in place. But what we've seen over the last 8 or 9 years, maybe a little longer, is we started seeing this mode of self-service IT, which led into actionable insights, which led to prescriptive, descriptive, preventative analytics. And all that stuff on the left-hand side is what we call time-critical decisions. And with time-critical decisions, the value of data to decision-making becomes extremely important, right? The key here is that you can't build a time-critical decision platform on your existing environment if you're just doing BI, right? So time-critical decisions requires a modern data platform and a domain-driven design mindset change. So it's a mindset change that has to happen. There's an organizational change shift that has to happen. And so these modern data challenges require modern solutions, right? And because of the way this shift has happened, and because of the advent of some of these technologies that are coming up, which we're going to talk about, as well as the advent of open source technology that's become readily available. This is not just this real-time modern data platform, time-critical decisions. It's just not for the Wells Fargos of the world or Cummins of the world or Bank of America. It's really become democratization of the infrastructure. So real-time, near real-time is becoming the norm and available just about anybody. And we're starting to see a lot of that deployment, and I see firsthand in our government and education, which typically has been slow to adopt new things. But so they're making in government education. In fact, I was just at Department of Veteran Affairs last week, where we're talking about embedding blockchain, AI, and ML through the entire data supply chain. So a lot of advancements happening in that area.
So Nitin, let me ask you a quick question here. Based on your interactions with customers, Can you share some of the more specific drivers for which organizations are, starting to look at data in this new light?
Yeah, I mean, there's a lot of drivers and motivations, right? So, I mean, some could be because they want to achieve greater responsiveness to lines of business, right? Or supporting new self-service, as I mentioned before, and the Citizen X approach, which is where your Citizen X is your integrator, your data scientist, or your data analyst. And an interesting example is what I'm working with the FDA, the Food and Drug Administration, because they really want to future-proof for new data sources. I mean, 5-6 years ago, they weren't even talking about Parquet and Avro and or data formats, but now those are becoming part of their normal discussions. So it's supporting these new data sources, plus ones they haven't even discovered yet, right? And even downstream application and use cases. So the idea is, and I should make this differentiation, I didn't say modern data stack on purpose. I said modern data platform because it's much more encompassing. It includes organizations, it includes people, processes, and technology, right? So that's the key here, which kind of dovetails. I hope I answered your question, Ajay.
Yes, thank you.
Oh, good. So as this kind of dovetails nicely into our into what's needed to be in place for a modern data platform. It's not about technology. That's where the modern data stack comes into play. It's these individual components that make up the stack. But with the modern data platform, we're talking about much more wider discussion, wider conversation. It really starts with an organizational transformation, as I mentioned before. There has to be a data domain and ownership change in how you address data, who owns it, who's responsible for, who is responsible for the trustworthiness of the data, which we're going to talk about here in a bit. So this also comes with the data as a product mindset, right? So you have to build data as a product as you're defining anything else as a product, right? How are you going to deliver that data? How are you going to expire the data? How is the data going to be released, right? And then there's this training. Obviously, a lot of this is going to be cloud architecture. So there's going to be an understanding how Terraform works. How are you going to provision data? How are you going to, deprovision your architecture? And then there's the processes, right? And we're not saying agile is the only way to do things, but that's probably been a more prominent role in some of our modern data platforms is the use of agile methodologies, not only in DevOps, but data ops and ML ops as well. And most importantly, and I got to stress this enough, is the data sharing framework. And I'm sure all you guys listeners out there are probably having to deal with this. You can't get a Citizen 360 view unless you have some level of sharing. If you don't have a data sharing framework, you're only going to get a 260-degree view or a 180-degree view of something, and that's not really complete. So there has to be a data sharing framework in place in order to get that bigger, wider view of the data set. So let's talk about some of the challenges, right? So a modern data platform is not, like I said, it's not something you just go purchase. It's not a SKU. It's really a mindset, and there's a lot of things that has to play together, right? And with the modern data platform, we have data that's everywhere. We have legacy systems, closed systems, we have transactional, OLAP, all these different databases out there. Now devices are generating data, and we have social media feeds that are generating data that have to be ingested. And this comes in different forms, whether it's structured, unstructured, semi-unstructured. For example, we're working with some state agencies that are dealing with traffic data that's unstructured data that has to be ingested in micro batch data. They have ERP data for their police officers that has to be ingested in the streaming fashion. So it's structured on streaming, and there's micro batch way of processing some of the weather data, right? So there's all these different ways to process and handle these data, but there's operational challenges in this. One, because there's data silos, as you guys probably are dealing with right now. And there's data sharing issues, right? How do we ingest this data? How do we get a bigger, broader view of this data if we don't have a data sharing platform? And then if we were able to even get some of these silos and sharing in place, how are we going to even ingest this data in a meaningful fashion with all these different formats such as Parquet, Avro, these open formats, as well as even our traditional formats, right? How are we going to ingest this? And what is the velocity and volume of data we're going to be able to handle? And that dovetails nicely into like centralized data management. Can our data management team even handle this level of inflow? And this is where the data product and data domain ownership comes into play. And again, different vendors have different ways to solve this. I think Holger mentioned it, and even Mike mentioned it earlier. Is we have data warehouses, we have data lakes, and we have data lakes houses. And by now, you guys hopefully you've known, come to find out that data lakehouses are not just coupling a warehouse and a lakehouse and just mashing it together. There's a lot of intelligence. There's vectorized IO, there's smart caching, there's smart scanning capabilities. There's a lot of intelligence built into this lakehouse. It's not just cobbling two different terms together, right? And then we have data mesh and data fabric. And I'm not going to go into each one individually what these things are. My point is that there's so many different ways to handle this thing. And what I'd like to do is take all that stuff aside, the implementation detail, all that aside, and really focus on really what the ecosystem should provide. And again, I want to emphasize this is our approach. When I walk in to talk to customers, whether it's the Treasury Department, the Veteran Affairs, FDA, or even state and local and these universities, I have this mindset, which is regardless of what ecosystem, whatever implementation you go with, the basic tenet is that it should provide the platform should provide secure access to trustworthy data as and when needed, enabling that data experience. Yeah, I know it sounds like a mouthful and it says a lot, but every one of those words that that are up there are precisely mapped to a specific area of function, right? And I'm going to go through this a little bit here to kind of explain what all the secure access to trustworthy data means, right? And then we'll talk about some of the technologies that go with it. So as we talk about secure access to trustworthy data, I talk about it in the context of the FAIR principle, right? The FAIR principle states that data should be findable, addressable, interoperable, and reusable, right? So it all starts with findable. If I can't find the data, if I can't discover the data, I can't even start on my data journey, right? So findable is important. So findability, discoverability starts with that data catalog. As Holder mentioned, how important the data catalog is. It's become so more prominent. In fact, my first job out of college, I was a data classification guy, and I thought, God, this is a miserable job. What am I doing here? But I'm starting to see the importance of how important a data catalog is, because you're tallying the data and you're applying data governance to it and applying good data security to it, right? So secure access starts with that findability of the data using a robust data catalog that reflects, this is important, semantic consistency. Right, semantic consistency is important, and it's got to have good governance. It's got to have good provenance and data lineage. So this data lineage, when we talk about that, it means who produced the data, why was it produced, when was it produced, and where it lives, and when does it expire. Just like data is a product, the data must have a life cycle to it, and it's got different versions to it, right? So all that is identified in the catalog. And as I mentioned, the security part is really, really important, because this is where we apply the attribute-based access controls as well as role-based access control. And this came up in, I think, Mike's presentation earlier. So let's talk about trustworthiness of that data, right? So trustworthiness of data, when we talk about that, it's the belief in the validity of the data set from the source, the ingestion, through the pipelines, all the way to the dashboard. Now, if you have cracks in our pipeline, if you will, we're going to have data downtime, right? Data downtime is bad. And the data downtime, what it does is it comes in the form of malformed data, incorrect visualization, or data unavailability. That's not good. And some of the leading causes of data downtime or trustworthiness is really the freshness of the data, right? Because the data is maybe old, it's stale. Somebody did a copy from point in time copy from like last week, and now I can't, I don't know how good the data is because it's not fresh. Or somebody could have made a schema change. This happens so often, is that somebody altered the data type or added a column or removed a column, which is even worse. Now I have breakage in my data pipelines. And again, lineage is really important. If I don't have lineage, I can't trust that data. And finally, I'm going to end it with this thing, is that data availability, right? So we always talk about data availability in the context of being access to data. And that really comes in the form of making sure your database, your data store is available. If you have downtime in your database, that's part of the trustworthiness of that data sets, right? And it's interesting in the industry, if you look at it, if you guys follow the industry at all in the data management space, some of the highest focus has been in this trustworthiness of the data pipeline, specifically data observability, right? So data observability has been a key discussion point about how do I make sure that my data pipelines aren't broken, right? So trustworthiness is important. So let's move on to as and when needed, right? So when we talk about as and when needed, if I have access to data, since data is democratized, it's trustworthy. Trustworthiness is there. I shouldn't have to wait 2 weeks for data, or I shouldn't have wait for days for this data. I should be able to access the data as and when needed because I have mean time to analysis, I have mean time to decision to address, right? And if we're still copying and cloning data, that's not a good thing because it directly impacts our mean time to analysis. But not only that, it affects our data governance because we may have PHI, PII data in there. So if you're making copies of the data, it may have data sets in there that shouldn't be left lying around, right? It also impacts our operational costs. And obviously it affects storage costs because you're making clones of this stuff, right? So what do we do? How do we address as and when needed? Well, there's a couple ways to address this. One is application integration, which means we're going to access the data between application to application or query in place. And sometimes that's the only way to do it because maybe your data sets are third party or they're in S3 buckets. They're not owned by you. So you have to query these in place using REST APIs, SOAP APIs, or other APIs that are available to you using MuleSoft or whatever it is. And then there's data integration or stream analytics, right? There's the other approach is pull data or access the data as it's being generated. We call this streaming analytics. All right, this is a very event-driven technology. So there's different ways to approach and access data. The day and age of copying and cloning data is an anti-pattern in the modern data platform.
So Nitin, a quick question on this. Can you elaborate a little bit more on the differences between application integration and data integration? When do you choose to do either of these integrations and in what use case scenarios?
Yeah, so the use case is really going to be depending on the data SLAs. And I'm going to talk a little bit more about this in the next couple of slides, but I'll address your question now. So query in place means it's really application integration, which means we're going to create connectors between two or more applications so they can work together between the two applications. And by unifying these apps workflows and merging the data in real time, the integration really eliminates data silos. I'm sure many of you guys who are listening are probably already using APIs right now. So application integration is also a way for organizations and lines of business to connect cloud-based and SaaS applications to on-premise and legacy systems, so that end users can use newer tools. And here's the key. So the end users can really use newer tools and technology with their existing systems. That's kind of the key there. So from a data integration perspective, just to kind of answer your final part of your question, is data integration is the process of taking data from sources and different formats and combining them into a single or multiple data sets, but making it more data usable. And this could be done in batch integration or real-time integration, right? So data integration is really is taking data from the source, maybe doing some transformation if and as needed for that approach. That answer your question?
That makes sense. Yep, thanks.
So our final piece in this little journey here is participation in that data experience, right? So when we come full circle, as we're producing data, we're producing it for something, right? So someone, it's the consumers. And this is all part of democratization of data, which means securely accessing data using attribute access control, role-based access control, and data visibility. And a lot of this revolves around using tools that provide rich prescriptive, descriptive, predictive analytics with explained visualization. And we're going to talk a lot more about our use case example with Medicare. But really, it comes back to data as a product, enabling that data sharing, right? If I produce something of value, I want to be able to share it. And that goes back to our FAIR principle, where the R part of it, which is the reusable part. I want to be able to produce something that somebody else can leverage. And it doesn't have to be just data sets. It could be a data model. It could be a visualization, or it could be actual data set, right? Okay, so up to this point, I haven't even talked about any technology, and that's purposely done because I don't want to just come in here and throw technology at you, right? We've heard some great presentations from Mike and Holger, and we're going to hear some really good things from Alexi. What I wanted to do is set the stage and talk about how is our conversation happening with our customers, and how are we approaching this problem of modern data platform. We just don't come in there and say, hey, here's a set of SKUs that you guys should go do, right? So let's map some of these technologies from the previous discussion, from secure access to trustworthy data, right? So we have all these different sources that come in. So a data platform, again, is a complete solution for ingesting, processing and analyzing, presenting that data to consumers. That has to be the tenet, right? That has to be our kind of a mission statement for the data platform. But as you see, the slide shows where the data lakehouse fits into their broader picture, right? So a modern data platform should be able to do this securely at scale with no copy contagion and providing that great data experience. And one of the things I should really emphasize here is that as we move our customers from our legacy platforms into this modern data platform, we want them to do that in a non-destructive way and also leverage existing investments. So if you have existing investments in, let's say, Informatica, DBT, which we use quite a bit, or Fivetran, whatever it is, makes us, rationalize and standardize and see if that makes sense for you in the next 3 or 4 years, or do you want to evolve that into something else to support different formats? The idea here is to leverage existing investments and rationalize and standardize where it makes sense, right? So for example, I've done several projects where we were doing data transformation using Fivetran and using DBT for the ETL and actually loading that data set into Exadata, all using Airflow DAGs. So it's all possible. We're not saying use this. This is the only way to do it. This is just a sample of environment or sample configuration that you can deal with, right? So having said that, I want to focus on some of the key interesting things that we've done within Oracle as far as the deeper integration. Again, the whole idea here is to drive mean time to analysis and mean time to decision making, right? And Holger already talked about this a little bit, so I'm going to kind of go into a little bit more depth on it. So let me define the problem statement first. We've been working with a lot of customers that are using S3 buckets or object storage, and data sets either get produced in these data lakes or they get copied there because of external data sets. But one of the big problems that we see is that once data is persisted in a data lake, in order to expose these data sets within a lake house, you have to create external tables as a representation, or the alternative is to ingest these objects. But we don't want to necessarily ingest those objects because sometimes we have to leave them in place, and sometimes we want to leave them in place because of cost reasons. It's cheaper to put it in object storage or S3 as opposed to bringing it into the database. But it's very error prone. Creating external tables, as Holger mentioned, is very time consuming. It's error prone and many times unnecessary, right? And because we want to maintain these objects in the data lake, we want to maintain that level of exposure in those in that platform. So as part of our mean time to analysis and mean time decision, we've accelerated this flow by tightly integrating the data catalog with object storage and our autonomous database. So let's kind of walk through this. When data is produced or stored in the data lake, let's say object storage, Harvest scans that object store and derives metadata. It derives things such as foldering information, logical entities, your tables, your columns, your data types, when it was produced, what was the harvest time, all that metadata is there. Now, again, the harvest could be done on demand. You can do it schedule as part of data catalog, or you can even create Lambda style functions that trigger anytime a file gets loaded that a harvest happens, right? There's different ways to harvest, but the key here is that once it's harvested, you can tag these entities and associate them with business glossary terms and just create metadata and make the files, which look like files in a folder, be much more representative. But once they're tagged and all those things are done, and that integration is done between autonomous database and our data catalog and object store, ADB instances connect to this data catalog and automatically share this metadata. And they appear in autonomous database, as Holger mentioned before, is that they become fully managed schema, tables, and objects whose the source of truth is in the data catalog. And this is really powerful because I never had to write any code. If you remember my automation or my modernize with the purpose theme before, we want to use low code, no code as much as possible. We want to use automation as much as possible because we want to drive mean time to analysis. And that's the key here. And Ajay, when we go through a demo, he's going to showcase a little bit of that. So what are the benefits? Once I have data that's in object storage and I can externalize those things and make it look like they're localized within the database, it becomes very powerful. I can run autonomous queries, against any one of these data sources, whether it's in object stores, S3, Azure, GCP, or wherever it is, right? And the cool thing is that we support all these different open formats, Parquet, ORC, JSON, Avro formats, right? They all just look like files to us, and they all look like they're tables within the database. And the cool thing here is that the native security capabilities that are built into the Oracle database can be applied to these data sets, because they just look like local objects within the database. So I can use semantic primitive capabilities that are already available within the database to apply these security policies. And finally, as Holger mentioned before, there's some performance issues that could always come into play. There's some optimizations that have been done within Autonomous Database to allow dynamic auto scaling, to leverage smart scan capabilities to produce a faster data sets, even data pruning for partition support, and Parquet intelligent reads. So there's a lot of advancements that's been done to improve the speed, especially when you have a mixed workload. As we're going to show you in our Medicare data set, we have half our data set that's in object storage, and half our data set's been streamed into our Autonomous Database. Again, this goes back to my modernize with a theme. As you modernize, we're not just upgrading a stack, right? Modernizing doesn't mean upgrading the Oracle database, which we all want you to do, right? And it doesn't mean just upgrading your data integration tools, your informatical tools, or your DBT, whatever it is. It's not just that, which you all should do. It's really about improving processes and increasing operational excellence, your day one operational excellence. That means using automation as much as possible. Use fully managed services or Autonomous Database to offload those mundane tasks and focus on really the high value efforts. Look at infrastructure as code for provisioning. Look at low code, no code approaches within your data pipeline. Leverage AI and ML throughout that cycle if possible. We have machine learning built into our data catalog. We have capabilities with auto ML for data preparation and transformation. And obviously AI and ML is built into our analytics. And finally, plan for different data types and multi-model data processing, which the formats you're going to use today may not be the formats you'll see in 2 or 3 years down the road. All right. So let's get to our customer use case and jump into our demo. Hopefully I'm doing good on time here. So let's talk about our customer use case. In this case here, we're I can't give away the name, but we're supporting an agency that has healthcare and healthcare and advocacy program. Specifically, it's Medicare, right? So this customer wants a broader view of Medicare consumption of services, right? Not only that, they want to be able to load and ingest this data very quickly. It's taking days to load this data, and that can't be, again, that's an anti-pattern. We want to be able to load this data very quickly and produce clean data sets and get it in the hands of these decision makers, right? And we also want to create a secure data sharing framework across agencies. And that's been the biggest fear across our lines of business, whether in the commercial space or even government, is that I don't want to be responsible for sharing data that shouldn't be shared, right? But that comes from a higher up, and that's a decision that has to be made as far as how you define that sharing, who gets the access to data, and it's role-based access, attribute-based access control. And most importantly, what this customer really want to do is really democratize data, but they also want to democratize that data platform. So once they build this modern data platform, they want the rest of the agencies to fold in. So what we did as part of this deployment is we started with the domain specific use case. And we have purposely avoided the term low-hanging fruit, because low-hanging fruit has bad connotations. It means it was simple, it's not representative. So what we did is we took a representative use case that can be applied to all these other different workloads, different agencies, and different domains, and build on top for that. So anytime an agency wants to sign on, it should just be a subscription level sign on to them getting onto that data platform. And again, finally, we want to future-proof for new formats and sources, and automate as much as possible, like I said in my previous slide, right? So this is kind of like the requirements, if you will, of this journey. We had to do this before we agreed to move forward with that modern data platform. And just to kind of, before I kick it off to the demo, I wanted to kind of talk about how we workshop this. We started with a clean slate diagram like this, We knew we had different data sources that were gonna come in, different file formats, different ways to ingest the data. Well, one of the things we did agree on across the board is that we're going to use an autonomous database. And the reason why we did that is because we knew the skill sets weren't there to support this. The manpower wasn't there to support all the requirements or even the provisioning, right? We would have to go procure some hardware, which is going to take a long time. So we decided to go with OCI, autonomous database, because it's simple to deploy, and all the backups, the patching, autonomous data guard, all those capabilities are built into autonomous were available to us on day one, right? We didn't have to go provisioning additional stuff. So this is how we started out the discussion, with over several iterations of workshop conversations. This is what we, I think Ajay will show it to you. But again, I wanted to mention the autonomous. The reason why we chose autonomous because the multi-data type support, the OML, the data science function that are built into it, but it also gave us a capability of having security on day one. We had CloudGuard. If you guys don't know what this is, you can reach out to us. CloudGuard, security zones, data safe, and data catalog are all day one things that we set up. Actually, before we went live, all these things are set up. So we had security on day one, and it gave us operational excellence right out the gate. And I'm going to skip this part because I'm going to give it to Ajay, but this is basically shows you some of the low-code, no-code approaches you use with OCI Data Integrator. And this is a slide I meant to show you. So this is the broader perspective. This is how we're going to fold in the Health and Human Services overall agencies into this modern data platform. Now, again, if you can see in the bottom here, the chronic conditions, that's the one data set that we decided to use. And we were going to focus on that initially. I wouldn't call it, like I said, we're not calling it low-hanging fruit. This is our reference architecture that we're going to build for all the other agencies, all the other workloads, and all their other data types that are coming in. So as far as the demo, this is what Ajay is going to go through. We're going to talk about how the harvest process works, how the data catalog works, how we can find things in the data catalog, talk about some of the deep integration on how the files and how data object storage and data storage shows up in autonomous, and how we can get mean time to analysis. And what does that mean from a visualization perspective from our analytics cloud? And with that, I'm going to turn it over to Jay to take over.
This is Roger just saying, I'm afraid we are running up on time, and Ajay, I was going to ask if it's possible for you to do this in about 6 or 7 minutes. It would be...
Oh yeah. This demo is going to take 3 minutes.
Okay, perfect. Thank you so much. Sorry.
4 minutes at most, yeah. We can't hear you, Jay.
Yeah, you're muted, Ajay.
Can you hear me now?
Yes. Sir.
Wonderful. All right, so I'll start at the end, and I'll show you, this is the end result of, starting with the ingestion process, running the data through the pipeline. And this is basically what we were able to create. So we were able to create some dashboards. We were able to use the out-of-the-box features that OAC provides. OAC is the Oracle Analytics Cloud. Use natural language generation and generate outputs and insights like this. So now let me show you quickly how we got there. So we started off with this data set being ingested using SFTP. It landed in our object store. These were two distinct sets of data. They didn't have anything in common. But we then said, okay, is there any commonality that we could derive? So we got to the join condition, which I'll speak to very shortly. So we kind of did some basic expressions. We did a filter on the first set, which was in the object store. And from there on, we basically, the transform data, we decided to put it back into the object store. So we had the raw data set, and then we had the transform data set back into the object store for consumption if somebody else wanted to look at that transform data. We did something similar with the second set of data. So this was chronic condition data. This was the Medicare claims data. We did some filters, join expressions, and then we said, okay, we need the exact same thing done with this set of data, but then we wanted to do some correlations between these two distinct data sets. So we said, let's create a join condition. This is all low code, no code. We are not getting into a scripting language or a programming language. within Oracle data integration, we created a join condition. And then we said, we now need to be able to store the resulting data set post join condition in two different places. We wanted our internal customers to have access to it in the autonomous database. And then there was another requirement where this was like a third-party reference location. So we also were able to connect to an AWS S3 bucket from within OCI and dump that result set in that object store, if you will. Just to give you a quick overview of how things look in the data lake. So this is a bucket in the OCI data lake object store. And as you can see, these are raw data sets that came and landed there. We were able to convert those data sets. So this is yet another data set with county SNAP information. One was the raw data set. We were able to transform it using another data flow and convert that. As you can see, we have different types of data types. One is a CSV, the other is a WAV file. You have JPEGs. So obviously the object store is able to support all kinds of data types. We talked about automation, how data catalog is the central glue that helps connect the objects that come and land in your object store and the relational objects that exist in your autonomous database. And it's not, going back to what Nitin said, this isn't just independent pieces that you are then required to integrate and coordinate. All this automation comes out of the box, built in, and we'll take a quick look at what that automation looks like. So as you can see here, we have 4 different types of data sets. So if I go into the data sets, you can see I've got an autonomous database called CMS ADB. I've got an object store bucket. I've got yet another object store bucket, and this is yet another autonomous database. I've got all these entities, and as you can see, you can search and you can filter on terms and tags that you want to search on. As you can see, these are split across autonomous database, data warehouse, the object store, so on and so forth. You are able to create glossaries for these objects, which come and sit in your object store. And you're also able to assign categories and terms. So if you want to search on these things, and I'll get to that here shortly in the next screen here. Real quick, this is the CMS object store data asset, and I wanted to show you how the harvest job works here. So if I go back and show you, this is the CMS object store connection, and we are into the harvest screen. These are all the objects that you just saw. I'm able to select this one object and move it in, and I say this is the object that I want to harvest. If I click on next, I can set, do I want the harvest to be an incremental harvest? Do I want to include any unrecognized files? And now here I have a choice to again automate this further, so I'm not having to go back into this harvest job again and again as new objects are coming into the object store. I can schedule this job. So the moment I say I want to schedule this job run, it lets you configure your schedule, and then you can basically create the schedule to run at whatever frequency you want this to run at. That way, as new objects come into your object store, the automation is built in, and based on the criteria that you've selected to incorporate these objects or harvest these objects into your autonomous database, the harvest job will run behind the scenes. And it will create external tables in your autonomous database, which you can simply query as though they were physical tables, or actual physical tables residing in your autonomous database. So real quick look at the autonomous database. This is what it looks like. You also saw this in the demo that Mike gave earlier. So it's telling you this is an ADW. The workload type is data warehouse. This is the name of the database. It tells you what the OCPUs are assigned to it, is auto scaling enabled. So all this automation about performance requirements that in an on-prem world you may have to size for worst case scenarios. All of this is just available out of the box, where you can auto scale both CPUs and storage if you wanted. In this case, we haven't auto scaled the storage. So this is a quick look at the autonomous database. And then You looked at all the tools that Mike referenced that come out of the box with the autonomous database. You have these development tools, you have the data loading tools, administration and monitoring tools. You looked at the performance hub that Holger referenced in his presentation. And here's the final kicker. So what happened is it created external tables in the autonomous database. We were able to create views off of those tables. And then I was able to combine all those views using, an all. So this is just the name of the view, which combines all the views using a simple union all. And then I'm able to run this query, simple SQL query. And from an end user perspective, I don't care where this actual physical data set resided. This could be a CSV file, this could be a JSON file, it could be an Excel file or a Parquet file. Once the harvest job runs, it's basically generated the external tables, and you're simply querying this as though this is a physical table residing in your autonomous database. So, and then again, coming full circle, you can then create analytic dashboards by querying the same objects that we just queried using the SQL to showcase visualizations and dashboards from a front-ending perspective. So that was the demo. Nitin, I'll turn it over to you to finish off the presentation here.
Thanks, guys. I'll make it quick. I just kind of want to end it and kind of summarize here. We talked a lot about modern data platform. As you can see, this is kind of representative of how we start our conversation with customers. Next slide. One of the things I want to emphasize here is, one of the cool things that happened over the last, 8-9 months or so, as we started seeing this pattern of building the same environment over and over again. So what we've done is we have reference architectures that build off pattern architectures that include some really the key components of modern data platform, which is the data catalog, data integrator, analytics cloud, autonomous, and all the things that come with it. Now, normally, it would take me, being an ex-consultant, it would take me anywhere between 200 to 300 person hours to go build that whole environment out. Not that doesn't include the data, moving the data, but just provisioning that environment, getting the right architecture in place and getting the right plumbing in place. Now, what we've done is we've created a pattern architecture that already has everything baked in. And if you go to this link, I think it's going to be in your PDF. If you go to this link and you click on automation, what it does, it builds out that entire architecture for you, including the compartments, the networks, it deploys data catalog, integrator, all those things that you see here. This is great because if you're trying to do a POC or POV, or if you want to do a real world rollout of an environment, this builds it out for you, and it does it in less than a week. Most of it is really planning. The actual execution of this thing is pretty much a Terraform script. And again, you can augment this thing by adding your own tools and other things, but it gets you started. And rather than spending 200 person hours or 300 person hours for this, it can be done very, very quickly and get you rolling. So the key here is that once you get it rolled out, you can focus more of your attention on data migration and implementation of your data pipelines. That's the goal here. And with that, I think, what's the next slide? Yeah, that's the implementation. This is what it actually builds out. And again, our mission is to help people see data in new ways. We'd love to help you. Although I work in government education primarily and work on strategy, I'm always here to address and handle any questions you guys have. So fire away if you need to in LinkedIn or even on that Slack channel. So thanks for your time, guys. I know we went through this pretty quickly. It's a deep dive on what a modern data platform should really look like. Thanks, guys.
Yeah,
Yep,
thanks so much. I think we're going to rush straight on. Guys, thanks. That was really a whole lot of information together. Please remember, everybody, these are archived, and you'll see them if you join the Slack channel. You'll see it pretty immediately. But I think we're going to move straight on to our next speaker. We are likely to go over the 1 o'clock. Depending on your time zone, the top of the hour. But Alexei, obviously we want to hear what you've got to say. So